Here's our Ollie class energy, environment, and economics, a biophysical approach. This is lecture 4, human cultural evolution. And basically, it's about the main ways that humans have increased their use of energy to increase their at least short-term fitness um, over human relatively recent cultural time. And by relatively recent, I'm talking about the last 10 or 20,000 years. Um, and with a focus on more recent things. So here are the main things that humans have devised culturally. Fire, and I don't know if we know when that occurred initially, more than 20,000 years ago, I think. And the most important thing about fire, which is, of course, energy, is it greatly increased the ability of human to exploit their environment for food. Um, Animals are relatively easy for humans to digest. Plants are harder for humans to digest because they have cell walls. But if you cook plants, they then become good food. Um, and and that greatly expanded the amount of food that we had from an environment. Humans for a long time have used spears, knives, and axes, which all are various kinds of energy or force concentrating devices. So if you take the energy of a human, of a fist, and try to pierce the skin of an animal, you can't do it. But if you hook that to a spear or a knife blade, you can cut that skin or muscle much more readily. So it greatly increased our ability to exploit the land as an axe with a sharp edge to concentrate the energy allows you to cut down much more readily trees. Can't do it without the axe. Um, and this has generated an increasing ability to exploit resources over time. Much later in human cultural evolution came agriculture. Um, and each of these in time generated an energy surplus, which initially allowed humans to uh, have more energy for themselves and their children, but eventually the surplus has been mostly taken up by an increase in human numbers because you have to divide the amount that you exploit by the number exploiting it. And over time, per capita has increased, but not nearly as much as the total flow from the environment to our species compared to other species. And this has resulted in the expansion of humans. And here are some specific topics we will cover. Exploration and colonization, that is a movement of different groups of human around the world. Uh, and this leads us to understand Hadley cells, how important that was to understand what was happening as people tried to sail around the world, the impacts of colonization, the formation of fossil fuels, exploitation of fossil fuels, coal in the Industrial Revolution, oil, nature's premium fuel in the origin of the modern oil industry, which was not Pennsylvania, but was Ontario. Okay, human cultural evolution is about increasing energy surpluses. And this is an idea that is attributed mostly to the uh, sociologist of the middle of the last century, Leslie White. No, excuse me, got the dogs again. Um, and Now we're going to start with,
Okay.
so the initial way that humans exploited agriculture, permanent agriculture, after they sort of had little garden plots around their kitchen middens, um, was shifting cultivation. And this, for a long time, was the dominant kind of agriculture, and even done in the Carolinas in the United States in 1950s, and in Finland still happening, I think. And so shifting cultivation, the basic problem with agriculture, as soon as you plant the crops and clear the natural vegetation, you lose nutrients. And you take the nutrients out with the harvest, and you take the nutrients are leached out when the soil surface is exposed. If you have natural vegetation there, normally you'll hang on to your nutrient inventories. And in the case of the tropics, much of the nutrient inventory is in the trees. So if you go in and you cut down natural vegetation, and in this case, a forest, and you let it dry, and then you fire it, burn it. It's called slash and burn. That's where the term came from. And you're left with the nutrients as ash, which you can then come in and plant your seeds and get a very productive yield, as good a yield as you can get with permanent agriculture in the same conditions, more or less. And the important thing is, I'm going backwards here, is that you do it, you rotate your use and let the natural system come back. So if we look at this picture from Venezuela, you see a recent area just cut, and then an area that might be in crops or might be just abandoned, I'm not sure here. But if you look carefully, you can see areas where the forest is maybe 10 years old or 20 years old, and you let the forest come back, and ideally to 25 or 30 years, the nutrients are, you get a new inventory as the nutrients take it out of ultimately the rain or the soil coming in, and you start the cycle all over again. So it's called shifting cultivation. So this spread from the Fertile Crescent westward across Europe. And as it happened, you could see what would happen over time, that the native vegetation, the pollen in the bottoms of lakes, the pollen is recorded over time, and the natural vegetation becomes less and less and less, and the nettles and grasses, which are indicative of areas that have been cleared, become greater and greater over time. And oak, I guess, is, I don't know, is uh, re regrows in areas that have been cut and are perhaps drier. But anyway, you can see the vegetation change in the cores that you can take out of the bottom of ponds. So agriculture is spreading over Europe in this case, and over other parts of the world as well. And the yields can be, I guess, pretty impressive under the best conditions. And I mean, look at this grain. I don't know whether it's barley or wheat or whatever. On this great painting by Bruegel, he paints lots of very interesting pictures from the past. And you can see these people taking sheaves of grain to load onto a wagon to take into town. And here a woman gathering the sheaves, and men cutting the grain. And here are some workers that are having lunch and taking a nap. And there's the result, is they're cutting a piece of bread for lunch. Um, and here are old paintings of people doing all kinds of agricultural activity, collecting, and I don't know what's happening here. They look like they must be planting crops. I don't know. And raising animals. The nobility, meanwhile, in leisure, hunting, and while all this other stuff is going on. And here's a guy stomping grapes and another guy knocking acorns out of trees for his pigs, and somebody else, I guess, butchering a pig. So the agriculture would wear out the soil. And I even remember those terms being told by my grandmother from South Carolina. And what happened in the United States is we wore out the soils in the east, we traveled westward. This was especially understood in England and Germany. England dug up the bones of the dead horses and soldiers from the Battle of Waterloo, ground them up, and used the remnants to fertilize their tired fields. That would probably bring especially phosphorus into the soil. In 1850 or so, a guy named Liebig in Germany came up with his law of the minimum that you didn't have to add all kinds of nutrients. You just needed to add the element in least supply. And this was usually nitrogen, phosphorus, or potassium. So if you go to buy fertilizer today, it usually says NPK of, say, 30, 10, 10. That meant 30% nitrogen, which is you need more of, 10% phosphorus, and 10% potassium. And then, of course, you can buy more complicated fertilizers with 25 or 30 different elements, every possible element a plant can possibly want. Now we come to exploration and colonization, and a very interesting book on this is called Guns, Germs, and Steel by Jared Diamond, and he makes the point that it was very easy to spread plants and animals in Eurasia, where in fact it happened. All kinds of animals were moved around, as we saw in the last lecture. Horses, for example, and wheat, because the climate was similar along this axis, where in Africa or in the Americas, you're going across very, very different climatic zones, making it much harder to move in small increments, especially agriculture from one place to another, agriculture or animals. And Diamond develops that in some detail in his book. But anyway, then came the big age of exploration, and it started from Portugal. And Portugal is very much connected to the Atlantic Ocean, and it was able to build very strong boats. And we might talk about that, but they began their southward exploration. And what they really wanted to do was go to India in that general part of the world and get spices. And they came back with the spices, which would give them enormous profits. At that time, a lot of the meat that was eaten was tainted because there was no refrigeration. So the spices could help cover over the taste of rotting meat, I guess. At least that's the story we hear. And a lot of this had to do with this guy, Henry the Navigator. And he created a school for navigation that Christopher Columbus went to, who was an Italian. He actually never went on a voyage of exploration, but he sponsored all these exploration expeditions that went down the west coast of Africa. And so the Portuguese and later the Spanish undertook this in spades. and eventually came over to the New World in these square-rigged ships, which were really quite marvelous technologies to exploit the energy of wind. Wind was a critical solar-powered energy. What causes winds? It's pressure differences, and the pressure differences are because of uneven heating of the earth. And we'll explain that in just a moment. So the winds tended to blow. The sailors did not know why, but the winds would blow from east to west in the vicinity of the tropics, and they would in northern latitudes they would tend to blow from the west to the east, and this caused them a lot of problems initially. And just to give you an example, here's a replica of the Mayflower. It took the Mayflower um, 10 weeks to sail from England to Massachusetts. 10 weeks.
Ow.
But it only took them 3 weeks to sail back. Now, that's what it means to go against the wind where you have to tack versus running with the wind, especially with a square rigged ship. Square rig, you see the main sails are square versus a fore and aft sail, which is like the single or double sail, small sailboats you see today. And so what they did was they generated trade routes. The first thing that the Portuguese figured out, coming from Portugal here, is they could get around Africa where the wind mostly blew against them. See this yellow line called labeled 2? If they sailed out almost as far as South America, let's get up here, and then they could, if they sailed from Portugal out here, where are the easterlies? Then they could catch a wind coming back. The wind down here in the South Atlantic is flowing from west to east. So the Portuguese figured out to get to around Africa, instead of beating into the wind, going around, going way out in the Atlantic and coming back. And they figured this out when people were really afraid to sail off the edge of the earth. They were able to exploit the winds and make this trip much, much faster. So an understanding of this didn't happen until this guy, George Hadley, lived 1685 to 1768, was a lawyer and amateur meteorologist, but he figured out what was going on. And the key is that the Earth is a giant heat engine. And if you over here on the right is the sun. Remember what I told you about holding up your hand perpendicular and parallel to the incoming sunlight beams? Your hand will heat up when you're perpendicular to the incoming photons, and will cool off when you're parallel to it. And the same thing with and everything in between. You can feel your hand warm up when you go like that on a bright sunny day. And so that means that the part of the Earth at the equator, which varies a little bit where it is from one part of the year to the next, but let's just say the equator in general, 0 degrees, gets the most photon flux density, the most incoming energy from the sun. And that causes the atmosphere, well, it hits the green trees of the tropics and causes the air to warm up, and warm air is less dense, so it rises relative to cooler air. And as it rises, it's pushed up from air from below, and that causes the air to cool and have less energy. And when it has less energy, the water in it falls out. So where does it rain in the earth? It rains on the equator. And this going north and south by 21 and a half degrees from summer to winter, our summer to winter. This is the thermal equator, and the air masses rise, create a high pressure area above the equator, which pushes the air masses north and south, where they descend at 30 degrees north and south, and then they come back to the equator again, which is low pressure on the surface. So these are called Hadley cells that George Hadley figured out back in 1800 or so. And these Hadley cells you see circulating like this, now the Earth rotates into this. Now the Earth is going faster on the equator because it's got to get around 25,000 miles in a time period of 24 hours. But a point on the 30 degrees north and south has got to go only around 18,000 miles in that same time period. So the equator is rotating into this Hadley cells, into the air masses that are moving towards the equator, and this generates what are called the trade winds or easterlies in the vicinity of the tropics. And these are the winds that the Portuguese would exploit to get around Africa. And then they would use the westerlies to go around the tip. Very clever. Now, they didn't understand all this physics, but they understood where the winds were blowing. There's a second cell that more or less the same thing called a Ferrel cell, but it's going the opposite direction. And that generates the westerlies that cause our weather to come mostly from the west. And here's a worldview of them. And somebody asked if this was starting a hurricane. Well, a hurricane is a different, much smaller cycle. These are just very large atmospheric, not particularly destructive winds. Okay, now then, as different types of different groups of people were spreading around in the world, they obviously would come into contact and often conflict with each other. Call that a clash of cultures. This had an enormous impact on, for example, Native Americans. And this is the number of Native Americans in central Mexico from when the Spanish first got in there, going from some 17 million, they estimate, down to just 1 or 2 million, mostly due to disease, but also due to armed conflict. And it's not a very nice history. Now, meanwhile, wherever Europeans went, they felt that the way to make your living was with farming and continuous farming, not shifting cultivation. And a wonderful rendition of this is John Perlin's A Forest Journey. It's a great old book with lots of old pictures of how forests were cleared. And just to give you an example from the United States, this is what Indiana looked like in 1800 or so. And this is what Indiana looked like in 1850, same place. All kinds, I suppose, much of the valleys around here were originally wooded. I don't know. There might be some historian who knows this very well. And with this clearing, we have agriculture and depletion of nutrients and loss of nutrients into waterways and silt and loss of topsoil. All of these things, this this natural ecosystem held on to its own nutrients, and this kind of landscape loses nutrients, which we replace with commercial fertilizers, which we'll talk about later. Okay, now the next big energy thing culturally that happened with humans was the Industrial Revolution. And when people understood that you could get lots and lots of coal out of the ground, and so people will go underground and spend an enormous amount of time and effort, and horses would live their entire life underground, hauling coal back and forth. Doesn't look like much of a life to me, but lots of people did it. And there were women underground doing this too, and children who were valuable valuable to those who were exploiting the coal because they didn't have to build as big a space to get the coal out, because the children fit in smaller spaces. So this led to a great deal of exploitation of humans as slaves or virtual slaves. The next thing that came along, and the thing that really propelled this, was the invention of, originally by Newcomen and Savory, and then with James Watt, which we'll talk about, especially a steam engine. The coal mines in England were deep underground and were flooding. So what the rainwater would come down the holes and from the ground and start filling up the mines, and they couldn't get the water out fast enough with horses. So there was a great economic requirement to be able to lift the water out. And so the original Savory engine, and these were very big things. They were as big as a room. And what he'd do is he'd boil water and generate steam, which is pink here. And he's got two valves, and he'd let the steam into the cylinder and push a piston up. And the piston would be pushing against air pressure. And so this would come up to the top. Then he'd shut the lower valve and open this red valve on the left and let in water, which would condense the steam. And that would bring the volume down to 1,000th of what the steam had been. And the atmosphere would push the piston down and would lift using the rocker arm, would lift the pump valve, the pump piston up from the mine, and that saved England's coal mines. It was even though they were horribly inefficient, because you're always heating and cooling this piston. It was could do an enormous amount of work, and it could pump a great deal of water at that time. And then came along Watt's engine, and James Watt certainly was a very, very clever guy. And he made this process of pumping steam into a cylinder. He first of all came up with the idea of pushing steam into both sides of the cylinder, and he'd use and he'd arrange it to automatically fill and empty the chambers. Let me show you how that works. So he's got a look up here at the top, and the red is steam and the blue is exit. So when he opens this valve, he pushes the power piston over to the left, and that pushes the old steam, the exhausted steam, out to the atmosphere. So he's not always heating and cooling the cylinder. Now, what he did is make this top valve change automatic relative to the power piston. And so you can see that in locomotives, so that they have a power um, a power rod, which I guess is this one. I'm not quite sure. And then they have connected with the same wheels the rod that runs the um, valve back and forth. It's just amazingly clever. And so he's pushing the piston back and forth, and each power stroke emptying the spent steam from the previous time. And this obviously greatly increased the efficiency with which coal could do work. And of course, you ever seen a steam engine in operation? It's quite magnificent to see. But the important thing is that the valve here on the top is connected with the power stroke. I can't quite see the rod that does that. These connect the different wheels together. But anyway, uh, excuse me, my dog has to come in. And here's an example of an original Watt steam engine. Come on, you see. Yes, yes. Um, and you can see they were quite large and they could do an amazing amount of work. Hundreds of horsepower, the work of hundreds of horses. And the second thing that they put in there was a regulator. So this spinning ball device, when it went faster and faster, driven by the operation of the main wheel, it would lift this up, which would reduce the amount of steam entering the piston here. So this would be called a governor and would allow you to run the engine at just the proper speed. Now, this allowed the mechanization of the production of clothes. And Manchester and so forth in England became known for these power looms. And my God, all of them are run by steam engines connected with belts made of buffalo hides, which contributed to the near extinction of American bison to get the skins to make these belts. And also look at those wheels in gears, and ladies had to wear skirts, and there were just horrible accidents when the skirts would be picked up into these gears and so forth. And the simple operation of covering these gears with steel or wooden cases enormously decreased the number of people that were hurt in these early industrial mills. Hair would sometimes get caught in all of these belts as well. It's just a gruesome situation. And of course, that led to increased slavery because they needed cotton for these mills and complications that England, for example, was more or less on the side of the South in the American Civil War because they wanted the cotton um, and so forth. But certainly the steam engine took off and completely reshaped. Probably the most important thing that ever happened to America was the building of economically, was the building of the railroads. Allowed the transport of agricultural produce from the Midwest to all over the country and wood from the north middle area and so forth. So here you can, if you're interested, you can read that in great detail. Here are the British coal fields in the 19th century. See quite a bit of it. And this brings us to one of my heroes, sort of, William Stanley Jevons. And my colleague If I can find this, where is it? I thought it was here. Oh, here it is. I just spilled a glass of water in my lap. Here's a book on Jevons paradoxes by my colleague Kent Klitgard. A nice little book available from Springer for $50. And so he writes in great detail about this fellow's life. And so what happened was Queen Victoria's advisors said, whoa, coal is really important in England. We need to understand more about what's happening with coal. So they gave the equivalent of a grant to Stanley Jevons. And he came up with this idea and he said, whoa, after 2 years, he said the use of coal is growing exponentially. And if this continues, then we're going to probably exhaust our coal mines. So this is the idea of depletion. And so then they asked him to go back and study it for another year, and he found out that they had twice before. Oh, so he said, so we must build more efficient engines. But this is already when the Watt engine was operating, which was fairly efficient, 2%, 3%, turning the energy of coal into the mechanical energy. And so they said that what we'll have to do is to increase the efficiency of our engines. But they had done that several times before. And each time they had made the coal, the engines using coal more efficient, they made it cheaper to use them. And so the net effect was to use more coal. And this is called Jevons paradox, that making the use of machines more efficient doesn't save the resource. It increases the use of the resource by making it cheaper to use it. And so this is, in fact, the history of the English coal mines. And it's almost completely exhausted by 2005. So Jevons' original concern, he said that the coal, if we continue to grow exponentially, will be exhausted in 200 years. And he said that about here, and he was a little bit ahead of time. I mean, it happened, I mean to say, it occurred even sooner than he thought. So fortunately, England discovered oil about here, and the oil was able to take over from the coal. So that's Jevons paradox, which is very important today because we face the same question with oil. So here's oil, nature's premium fuel. We've been through how you get a rift, the earth breaking apart in a tropical climate, and so that the bottom remains anaerobic. The water doesn't mix because the surface water is too warm. And then you cover it with sediment and wait 100 million years of pressure cooking. And then you end up with gas and oil, which we exploit with our oil wells, which are very deep compared to water wells. Oil is formed in source rocks and migrates up to these traps, which we exploit. And now we have learned with fracking to exploit the source rocks, and that's really saved our tail in the United States. Without fracking, we'd be in really bad shape. Now, I'm going to go through this pretty fast But we think that the oil industry started in Pennsylvania with Drake's well. He wasn't a colonel and he wasn't the first, but his name was Drake. And in Pennsylvania, in the first big oil boom in Pennsylvania, but it was actually in oil springs in Western Ontario. And by this guy, James Miller Williams. Here in how they drilled, they had a log attached by a rope to a Springer board, and I've jumped on this very board myself, and that's attached to a chain that goes down to an iron rod with a point on the end, and that's how they drilled the oil wells before they had rotary drills. Um, and here's the old oil fields in 1860 or so. And Fairbank came in 1861 and built, got quite a fortune and built these fancy mansions from the oil fields there in Ontario. And it was quite an operation. And here's my friend, Charlie Fairbank. Was a nice guy and used to come to my lectures and was real interested in oil. And we'd visit him when we were going through that part of the world. And here he is. And he has built these old statues. And here is an oil field that's still working. It's 100 and odd, whatever, 40 years old. And he's got this is a pump going up and down, and he's got these long links going back to pump houses where the motor is running them. And he gets just maybe a gallon of oil a day or a quart of oil a day, but uh, he got enough wells. And they're still working. You see, all of these are all linked to this system of rods moving back and forth. And it's also a wildlife preserve. He's very clean about it. And he's got these metal figures. And there you have it, the first oil field in the United States, in the world. So the point is the horsepower you're able to produce over time, it just increases enormously. And here's what it means. Here is the production of GDP from 1830 to 2010 or so. And here's the use of coal and gray, oil and red, gas, nuclear, hydro, and a little bit of other. And solar now, wind and PVs is still something like 6%. Most of the energy we're using is from fossil fuels. Fossil means old. Same for every continent. Let's see, that's Africa, Asia. This is the energy that's being used. Here's Asia again. Was that Asia? I don't know. Asia we have twice. And here's what it means. This is a 33 horsepower harvester. 33 horses, actually mules, and 5 people taking care of that. And then you have to have stable boys, and you have to grow the food for the horses and so forth. All of this taking place to run a 33 horsepower harvester. Okay, today, here's a 200 horsepower harvester. This is why we're rich, because we do so much more work per worker. It's called labor productivity. And labor productivity is directly related to the amount of fossil energy used per worker hour. So there you have it, right there. That's the critical thing. Going from this, where we were still rich in 1900, to this. And you can just see it go a little to the east where people are harvesting crops, or north. Now, the wealth spread from the few to the many, and all kinds of social conditions change. So here we are in a literary town, and people care about Jane Austen and so forth. And this is all what's happening with these gentlemen is that the wealth is going from the land to the cities where the industrialization is taking place. Because the basis of wealth used to be solar power in the land, but then became much more concentrated with fossil fuels in the cities. Here's wealth, GDP per capita in England. My goodness, look at that. That's due to industrialization. And in fact, if you go, you can go way, way back. And this, the colors are the proportion of the economy from 40 or 50% back in 1300 down to 10% today or less is the proportion of the workers of all the people working that are producing energy. Originally, forestry, agriculture, animal husbandry, which is the source of the energy to run the other half of society. And now, as we use fossil fuels, only about 10% of the economy is used to make the energy to run the rest. And of course, now we have these enormous expenditures to get oil and gas. And the population, which hardly changed over 6,000 years, has increased now to 8 billion people. And a lot of the understanding of how energy runs our economies comes from Howard Odum, my PhD advisor, published this book, Environment, Power, and Society, in 1973. The important thing is that the flow of energy on a unit of land used to go to all of this diverse creatures of all kinds, and the energy was passed on through food chains to all of these different critters, the energy coming from the sun. And we can look at it this way. Here is some native folks with their game in the forests, some small croplands, and small villages, and perhaps some herds. The same thing. We have the same thing, but the scale is massively bigger, massively larger number of people, and it's fed by fossil fuel, allowing this manipulation of nature into basically our mouths. And then the net effect is an enormously greater number. Going from a, Gloria, please turn your
Oh, sorry.
thing off. Yeah. And so going from many species, the energy going from many species to a farmer and to town. And these things, at one time, I was very interested in figuring out how you would calculate the amount of energy flow in calories per hectare per year or per square meter per year going into each of these things. I did this myself for Costa Rica, very detailed studies of where all the natural systems and the coffee and bananas and sugar and rice and maize and beans and so forth, how much for the whole country was going into these different things. I got 2 books on that, anybody interested. But that's, in general, it takes about 10 calories of oil to put 1 food calorie on our tables. 1/3 is spent on the farm, 1/3 in processing and transport, and 1/3 in storage and preparation. About 18% of all US energy use goes into food. So to just make a calorie of food on the land takes about 4 calories on the land itself. So we use 4 calories of oil on a farm on average in the US to make 1 calorie of food for our mouth. So think about that when you're eating. So you eat maybe 2,500 or 3,000 calories a day. So you use 10 times that of oil to feed yourself. That's about a gallon of oil to feed yourself. Okay, you can think of natural ecosystems like an oyster city, an oyster reef, being subsidized by the water flows that bring in food to the city in terms of plankton that the oysters filter out of the water and take away the waste and the heat. And like similarly, a city for the United States, the natural energy flows disperse the heat and the waste, and we use fossil fuel to bring in food into the cities. I remember being on the road at the wrong time, going into Mexico City, and there was 100 miles of trucks going in every day, bringing food into Mexico City. Without oil, Mexico City starved to death in a couple of days. So that's where we are today. It's where all of us look at all the trucks bringing food up Route 5. We see that every day. And as countries developed, Korea being a good example, I made this graph a long time ago, or Mexico, as they got richer, they used more and more energy. It's just more or less a 1-to-1 ratio of increase in wealth with increase in energy use. U.S. at this time was a little, I'm not going to talk about that. I will later. So here's just an idea of the difference between a natural cow on the rangeland and a beef machine with a great deal of fossil fuel going in to generate a steak in the beef machine, which is what we eat. So almost all economies of the world go through sequential, unlimited exploitation, depletion, and collapse of resources. And for example, I got this idea. I used to live in Montana for K. Ross Toole's History of Montana. The first big resource exploited by European Americans were beaver, then gold, then silver. This is about the period of their exploitation. Eastern dryland farming, and once you plowed the soil, it blew away. Copper was the big one. Timber is still taking place. Agriculture has gone up and is still more or less large. And tourists. So that's Montana. Here's Ecuador. Coffee, and then they had coffee disease and shrimp, wild shrimp, they overfished. Pelagic fish, they overfished. Trawled shrimp, they overfished. Shrimp aquaculture, I think is the yellow. Oh no, that's bananas. That it's the purple, and then white spot disease got the shrimp. Once you concentrated them in coastal ponds, you dig out, destroy the mangroves, make coastal ponds, fill them with shrimp until you got them too crowded, and white spot disease wiped out the shrimp. And then the big one is oil production, which has now peaked and is beginning its decline. And what's ahead for Ecuador? Well, they're having all kinds of political unrest. That's what happens every time you have peak oil, you have political unrest. And that's a whole nother story, which we'll talk about later. So this gave you wealth, that takes it away. Well, that's just saying how all of this, humans are here exploiting this whole food chain of energy. And as we use energy, we deplete it. The economist's argument is, don't worry, technology will overcome depletion. And the geologist argument or the ecologist argument is depletion is real and will overwhelm technology. Who is right? Well, I had to throw this in just to give you a little sense of credibility. Here's the English Parliament, and here's yours truly, not feeling as smug as I'm looking, giving a talk to the UK Parliamentary Committee on Energy. And I am saying, well, the North Sea will soon be depleted, which it now, 12 years later, it is quite depleted. But I was the first to predict it in Europe's House of Parliament, to my knowledge. And so here is my old friend Colin Campbell, not a kind of a fuzzy picture, but he was an oil geologist and a good friend. And he said with his favorite Guinness stout, the glass starts full, that's the oil in the ground in 1900. Drink half of it by 2000, by 2100. Eventually, it will be empty. So here's what we run our society on almost completely. I've tried to make that case, especially with respect to food. And here's where we're going. So, what are we going to do? What are we going to do about it when nobody has a clue? As far as I can tell, none of our leaders have a clue. One of our leaders has said, drill, baby, drill, but drilling more is like drinking faster. You're not changing the reality of how much Guinness Stout is in the glass. Okay, I am going to stop and I'm going to see if there's any questions. If I can get out of stop to share. And let's see, can I make a view where everybody is gallery? Here we go. Okay, hello. Meg has raised her hand. Yes.
Hi. Well, I was just going to point out, you talked about slavery in terms of cotton, but one of the first things that humans organized or exploited as a tool for food production, et cetera, were other human beings.
Of course.
And that totally, became egregious in terms of colonization and extraction of resources from other peoples and other countries, often destroying them in the process. Just a reminder of that. And GDP, as we see today, does not necessarily mean more people eat. It can mean, as we're seeing in our society, where there are billionaires and then there's the rest of the population who are at the mercy of people who have won the system or gamed the system. Just some thoughts about that.
Well,
so one other thing where you were talking about where the
a lot of people have talked about this, including Adam Smith, and obviously including Karl Marx and including lots of other people. And one thing to look at is the Gini coefficient, Ginni, which is the amount of whatever, GDP if you wish, that goes to the top fifth of society compared to the bottom fifth. And you can see how there have been various times in the United States, for example, where the Gini coefficient has gotten much larger, and we would think of in the age of super capitalists, what do they call it? The golden age? No, I can't remember the name, but in late 1800s, and that the Gini coefficient was very high, and then it came down during really during Franklin Roosevelt's period in the White House when there was much more, and especially starting in World War II. Now, when I was a paper boy delivering the Boston papers in the fourth grade, I used to read the papers in between customers. And I remember looking at, I don't know, the Boston Globe probably or something, in the front page, and it talked about how the wealthy paid 92% of their income to taxes. And I'm just a middle class kid. And I'm thinking, well, they're rich. They should. But that hasn't happened now. So that now, if you look at the special laws and so forth, the wealthy pay less as a percentage of their income than do the middle class. And this started with Reagan and increased with George the First and George the Second, and I think Clinton and Obama nudged it back a little tiny bit, but not much. I mean, the Democratic Party as well as the Republican Party is pretty hooked in with people with a lot of money because that's how you get things done, like winning elections. So the Gini coefficient, I believe, is pretty much as low as it's ever been. I mean, as high as it's ever been in the United States. And here's how it works. If you are a senator, every day you have to raise, I don't know what it is, but so many tens of thousands of dollars, or you will not be reelected. And so if you give a senator $30,000 for his campaign or her campaign, you're going to expect something in return. And so that's something that the founding fathers, who I thought wrote a wonderful constitution, didn't think. Now, that doesn't always work because you do it too much and you get a revolution, as the French found out in 1780 and the Americans found out, and now and again. And sometimes the political apple cart is turned upside down, and you can go anywhere you want with that. Yes.
The other thing you said is, that on your graph, it was how much of the food production, the natural process, a lot of the energy went to, the fields, et cetera, and the surrounding environments. But
Other species.
And other species. And by just following that to its nth degree, is we see the devastation of the natural world because it's not getting the things that it needs to survive.
So 99% of the biomass of all animals is either humans or the animals we raise. Greater than all of the wild animals and all of the animals in Africa, which are, of course, being greatly diminished. And as humans are growing, especially in Africa, they're still growing. So the answer to that, of course, is yes.
And even one example about oysters at the foot of the Mississippi, a lot of the water, or was it? I can't remember. I'm sorry about this, but the water in Atlanta was used, even though they were told this was a water shortage. It wasn't really comprehended, but the upshot of that is less water went to the Gulf, and therefore it devastated their oyster population.
I've got my best friend is from Louisiana State University, and has taught me a great deal about the mouth of the Mississippi, which is in Louisiana, and that whole process. And yes, what they're doing is they're making artificial levees, high banks. So the Mississippi has artificial levees all the way from the middle of Illinois down to nearly its mouth. And so the river is no longer spreading out in creating conditions for oysters, for example. The water is, they're trying to keep the ship channel deep. And then and basically what that's doing is we're no longer building land in Louisiana and we're losing 20 square miles of land every year because we're not allowing the Mississippi River to rebuild the land through flooding over its banks and dropping sediment. And so, yes, that's a big process, and we're having problems with anaerobic conditions on the bottom of the ocean, killing off the bottom fish, etc. Yep, everywhere you look, there's a whole bunch of them. I can give you a whole hour and a half on that if you want. Other questions? No questions?
If none, then don't stop the recording
Oh, well, okay.
because you can continue, you can start over and I'll splice it into the
Well,
beginning.
Eric, if you stay on, I'll redo the beginning of it and you can paste it
Right.
in.
That's what I'm saying. Just do it now. Whenever it's over, whenever you're
Yeah.
instead of closing it,
Well,
just
they're not as
start again.
active as they were previously. I have been so pleased with the questions previously, but they seem pretty quiet today.
Prospects are dim with this lecture. You know, things aren't going to get better. Nobody's addressing anything that even less now than what minor amount they were addressing it. I don't know, in another administration. So it does seem like things are dim and grim for the future. Nobody wants to talk about any of this. They just want to keep making money. I would just comment that all the billionaires and the rich benefit and the rest of us pay the big price. Everybody, and not just the rest of us, everybody pays the price, the negative price, and only a few get wealthy off of it. So, um, yeah,
Well,
it's brutal.
well, there's a guy named Rosen who made a good argument that human beings, on average, in the world, have never been better off. Now, he made that argument about 2015, and he had data to support it. And now that wasn't how much nature there was per capita. I don't think that entered into his equations, but the GDP per capita, even all the way down, uh, even our poor people are probably wealthy compared to the poor people of the past. And so a lot of times people evaluate their situation not relative to the past, but relative to their neighbors. And so a really important thing is people often feel worse off relative to other people that they see, as opposed to what they might be or what their grandparents were perfectly happy with. So industrialization has generated an enormous amount of wealth for an enormous number of people, even if Elon Musk gets half of it. Still a lot left over. So now we don't obviously have to go very far to find people that are not doing so well. In Ashland, we have plenty, but it's a complicated issue. And, I like to say that industrialization is a two-edged sword. It's generated a lot of benefits and a lot of disbenefits as well. Gail.
Well, I think it's interesting that for a while there, everybody talked about zero population growth because the more population we have, the more energy we're using. And over the weekend, our government came out trying to figure out how to promote people having more babies and increasing the population of our country. So he was talking about maybe giving every woman $5,000 bounty for having a baby. That's only going to make things get worse faster, isn't it? I mean,
I think so.
seems like these things are connected, but they seem to be totally separate in other people's estimation.
Well, South Korea is having a tremendous deficit of babies.
Mm-hmm.
And that's an extreme. And I can't tell you but they're trying very hard to promote. I think women they used to spend almost all of their time growing babies in their stomachs or lactating. That was what they did, period. And I think once women have the opportunity to do something else with their lives, many of them choose not to be baby machines. Although obviously, there are tremendous benefits to having children as well. But it does look like in the world, there are far fewer children being born, except in sub-Saharan Africa. The number of children per woman is still increasing there, but in other parts of the world, I think nearly all other parts of the world, few exceptions, the number of children per woman is decreasing rapidly. Rapidly. Mexico, rapidly. From 8 children per woman to 1.5. So I think that Mexico will start having a negative population growth. And my sense is let's have negative population growth for a while and see how that goes, and then we'll talk about it. But obviously, people are talking about this from very different perspectives. Carol.
Well, on that same line, it makes me think that they're looking for a certain race of babies, and it's mixed in with a lot of other issues. They want workers, but they want the browning of our population. Some people don't like that, so they want white women to have more babies. I mean, that's what I think some of it is about.
Yeah. Yeah.
It's a political statement I'm making, but that's what I
think we live in a very racist country. I mean, it's obviously mixed, but
well, I think they're looking for white women to have more babies, and thinking that they need to bring up that population more than anything else. But because I think there's a lot of other issues all entwined with this whole thing. But anyway, and it's true. It costs so much to have a child and to raise them, and then you're at, like you were talking earlier about someone's aspiration for how you want to live or what your children to live, and because there's an awful lot of the 9.9%, now I'm talking about the 0.01%, that are caught up in the same kind of rat race of home and car, education for your kids, retirement. And, we've all been kind of bought into the system to some degree, or been, our premises are all messed up, even personally sometimes. I mean, you may think you're enlightened, but it's really hard sometimes because you're caught up in the same system where you're told what is to value and things like that.
I think people our age can discuss this, but the problem is, from a very wide perspective, the problem is that the people who need to be discussing this in the different aspects as we do need to be, young teenage girls. Um, I think very often their values are projected from externally, and they haven't had a chance to really think through what they actually want to do with their lives. I don't know. What
Well,
did
no,
you
yeah,
think you wanted to do when you were 14?
I guess when I was, I mean, okay, that's another topic, and I guess I was thinking more like buying into consumerism. You have to have a bigger
Yeah,
kitchen, you have to have a better kitchen, and you remodel and you create all this waste that goes somewhere to be dumped, and your kitchen was just fine. Or you need a bigger closet for more clothes, for fast fashion that gets, out there churning up water and things. And I don't know, the whole thing, you get caught up into a value system so easily in our consumerism society that it's hard for younger people to resist or rethink it all,
oh yeah, and
and
they got all kinds of psychologists figuring out how to trick people into buying stuff they don't need.
right. And
Um,
you have channels on TV, you want to remodel your home, you go, oh, your kitchen's old fashioned, you got to get rid of your stove and it still works. And but you know what I mean? It just you get caught up in this whole thing.
I know, been there, done that.
Right. And and then when they keep talking about, oh, the GDP is good, the GDP. Well, we don't even talk about these other valuable variables, like the Gini thing that you were talking about. Those aren't even discussed. So, people are not thinking about this because the media doesn't even bring that up. And then you have this, roiling resentment going through society and creating politicians that we've got now that are exploiting it all. So I'm not really saying anything. I'm just ranting. So I'll stop.
Well, no, it's good ranting, and we have an ally. Where'd you go, Carol? Oh, there you are. We have an ally in PBS, Keegan Van Hook, and he did the Energy Horizon series. If I don't know if you've all seen this, and Eric, we ought to put the link onto your site. But I was part of a very good series on energy called Energy Horizons on PBS. If you go to Passport, you can find Energy Horizons, or you can email me. I'll send you the link. And I'm in the first and the sixth of these six very good sessions where they look at the future of energy in Oregon. And I think you could write PBS or Keegan with your ideas about why we need a discussion of values, or however you want to. Are you willing to do that? Would you like to do that? Because we can get you on PBS and other people that might be included here and others, but you have to be people who are willing to talk. And then you and me, he's going to do another series with me discussing some of these issues, and we might want to interview you on that. Are you willing to do that?
Me?
Yeah.
Sure, I guess so. I guess I'd better put my thoughts to better.
Will you
Put
send
them down
me an
a little bit
email
better.
so I have well, I can find it, but send me an email and I'll send the idea along to Keegan.
Okay.
All right? Come on, we'll
All
make
right.
you all put you all on TV so maybe you can have some impact, Carol. And our series here was broadcast spottily all over the PBS all over the country. Our Energy Horizons. I had a friend in Maine who turned on the TV at 11 o'clock at night, and there I was. So,
Check the chat log for the links.
okay, just make it clear for them to get there, Eric. So
Click on
Carol,
chat down at the
send
bottom.
me an email.
Yeah.
Okay, chall@esf.edu. Okay. Meg, another question. Yes.
Well, I was just in terms of selective breeding and also cuts to the funding for the elderly, the disabled, and support for the poor. I think that some of the people in charge are very fond of eugenics. That's what it feels like to me. And that would explain the discrepancy of encouraging some people to breed, but at the same time cutting benefits for the others.
Well, the people that are in power now, and I would say often in power, seem to value doing well in business, making money, and would choose to encourage people with, let's just say, money-making genes, if there's such a thing. And me, you know, I was kind of a countercultural hippie when I was young and long hair and 60s and all that. Although I was very serious about being a graduate student also. But I've never respected people who made a lot of money because I think there's no way you can make a lot of money without destroying a lot of nature or exploiting a lot of people, both of which I consider to be not admirable qualities. So if you put myself and some of the current administration on a panel to decide what kind of eugenics we want, we would vote for, they'd vote for the money-making genes and I'd vote for the opposite, or something like that. But I think I'm distinctly in the minority. The trouble is the masses of people can be brought along very easily by promising them a somewhat better standard of living. It's always been that case. You can't run for president on my platform. Okay, any more comments? Thank you for speaking up. How come the women speak up and the men don't? I think one thing that would be good would be turn more of our governance over to women, quite frankly, because I think oftentimes they have a better value structure. But boy, that's a sexist comment, isn't it? I apologize for that.
Well, there are some, strange women too in the MAGA movement, so we're not exempt. I
Yeah.
think white women did the majority overall vote for Trump, unfortunately. If you break down the demographics, you could slice it by age groups and things. But so anyway, we're not exempt.
And Ashland is not an area to get a statistically average American citizen.
No. Yeah.